Hey guys, my name is Sandeep Patel. I'm a founder of Slotify.ca. In this video, we are going to learn, we are going to solve a problem using recursion technique. So the problem that we are given is based on the array. So basically, given an array, we need to find an element inside the array. And we're going to solve this problem using recursion technique that we learned. If you haven't watched my video on the recursion, please do watch so that you can learn the essential of how we can solve problems using recursion technique. Alright, so let's get started. So in the recursion approach, there are basically two steps that we follow, right? So first is breaking the problem, right? And breaking the problem, and the second one is the solving the sub problem, right? So how do we break a problem, right? So for example, let's say that we are given an array 1 2 3, right? So how about we break the array, right, into a smaller elements. So let's break the array in such a way so that each time we can slice the one element from the array, and then it can go up to and let's say that we have initial array like this. Next time we can break the array, right? So we can call this function. Let's say that we call this function with initial array, right? 1 2 3, and then inside this function what we're going to do is call the same array again, but instead at this time we're going to pass only 2 and 3. We're going to remove the first element from this array, so basically reducing the problem into a sub problem, right? And then we're going to do this until we hit the base case, right? The base case meaning that until we have no elements left inside the array, right? So this technique is called breaking the problem, right? Where we took the initial problem and then we broke the problem so that we get to the smallest sub problem that we can find, right? So now the second step is solving that sub problem, right? So we're going to solve this sub problem where the array elements are 0, right? So can we say that when array has no element, we cannot find element inside, right? For example, let's say if we're trying to find 1 inside empty array, but there are no elements in the array, so this should return false, right? Okay, so let's solve that base case first, right? So step number 2, we follow first, we solve base case. So this base case is basically triggering when array dot length becomes less than equals 0, then what we do is return false, right? So now we can follow the step number 1, right? Breaking the problem, right? Breaking the problem, right? And how do we do that? So we're gonna call the same function again, contains, and then instead this time we're gonna slice one element from the array, right? And then we are also going to pass target, right? So basically we are calling the same function like this, right? So first time you have the initial array, and then this time we slice the first element, so we remove 1 from the array. Now it becomes 2 3, so it's gonna call itself until it goes to the base case where the array elements are array has no more elements, right? And that time it returned false. So now we cover this base case, right? So it is going to work for this base case, but how about this, right? So we need to put an additional logic here, right? Where we return true, right? So I would say when we find element inside our array, right? And how do we do that? So we know that whenever we're calling the same function, we are chunking down the first element, right? So how about we check this first element that we just took, right? And then each time we're comparing that first element with the target, right? So we can we say it like this? So we're comparing the first element. If it is the target, then we can say return true, right? We found our element inside. Okay, so let's run this code. And now you can see that when array is empty and we're trying to find 1 inside, and it's written false. If array is 1 2 3, we're trying to find 2 inside this array. We have the 2 inside, so that returns true. And the last one, we're trying to find 4 inside the array element 1 2 3, which we cannot find, so it's returning false, right? So this is how we can solve a recursion problem using two-step approach. Now let's solve the time and space complexity for this problem, right? So to find the time complexity is really easy. You have to check within this function, we have to check each statement and see how many times this code runs, right? And let's say if it's run multiple times, does it depends on the input, right? If it does depend on input, then we should calculate the time complexity of that particular code. So let's say that when we run this function, this base case, it only runs once, right? Because when array element is 0, that's when we return false, right? So this runs single time, so I would say it's one time. So complexity for this code is O of 1. Similarly, this base case, right? So this return happens single time. Each time we call this function, it runs this statement, right? So it's a single time, right? O of 1. However, this line of code here, so we are basically calling the same function. So this is a recursion, right? So we have to check how many times we call the function, right? So let's recap here, right? So the first time we have passed the array of size 3. And how many times we call this function? So we call 1 2 3, right? And then this is the base case where we return, right? So basically this function calling itself 4 times, right? Which is, I would say, it is calling until n, right? The input size, right? And this we don't count because it's basically returning statement, right? So in here it calls itself n times, right? So that's the reason why we call the time complexity of this code is O of n. And how about the space complexity, right? So in space complexity, we check to see if we are using any variables inside this function. So we haven't used any extra variables, therefore the time space complexity is O1. However, we also have to consider when function calling itself, it's adding those function call in the stack, right? So we also have to count the stack memory towards space, right? So what you need to know is that this function call itself n times, that means there are n calls in the memory stack, right? And that call stack should be counted toward the space complexity, right? And that's the reason why it has a space of on as well. Alright, so I hope you like this video. Please do like, comment, subscribe, and stay tuned for